Our next section is 2.3. We're going to talk about Venn diagrams and how they work with our set operations. So remember that a set is just a group of things that are related. And instead of talking about them in a list like roster notation or describing them or using set builder notation, you can also use a Venn diagram to help you visualize who's in your set, who's not in your set, and what two sets have in common. So this is our mathematician. This is John Venn. He lived from 1843 to 1923. So all of the things that you're using for today's section are over 100 years old. So here is an example of a Venn diagram. I am sure that you guys have seen these before. So what you'll see is usually you'll have 2 circles or 3. You can go bigger. You can have 4 circles or 5, but then it gets a little muddy. And sometimes you can have 1 circle, but that's not very interesting to look at. So you're going to see a rectangle around your diagram. That's an important part of your rectangle. And then you're going to have a U down here. So U stands for universe, and that's also the universal set. And that means that everything in this rectangle belongs to whatever the universal set is. So for this example right here, it's animals in the ocean. So this rectangle is the set of all animals in the ocean. And then the little circles in here are going to each have their own. They're going to be more specific. They're going to each have their own characteristics. So this circle I named whales, and this one I named fish. And then here are some just characteristics of both animals. So whales have hair, they give live birth, they breathe air, they live in the water, they have fins, and they can swim. And then if you look at fish, here's some characteristics of fish. They also live in water, have fins, can swim, but they lay eggs, they have scales, and they breathe in the water. So what this lets us do is it lets us see that all of these characteristics inside the blue circle are for fish. All of the characteristics in the red circle are for whales. And what you have in between right here where the 2 circles overlap are characteristics of both whales and both fish. So this helps you visualize what things have in common, which is where the circles will overlap, and what they don't have in common, which is out here where they don't overlap. So here's just some more words for you. So the universal set is represented by a rectangle. That's for a rectangle up here. And it's a general set that contains everything we're talking about. So for this example, we're talking about animals in the ocean. It could be anything. And then subsets within the universal set are going to be with circles. Sometimes you can use ovals. I don't really see other shapes, but I guess it's possible. So that's just some words to get us started. Okay, so here we have an example. Here's my Venn diagram. So we've got a rectangle. Here's U up here just to let you know that we're talking about this universal set. And then this circle is going to be named A. Instead of being named something like whales or fish, you can also just give each circle a letter name. So I need to use this Venn diagram to determine who's in the set U, who's in the universal set according to this Venn diagram. So I need to go find all the things. So inside the rectangle, there's a square and a triangle. So I'm just going to draw myself a square and a triangle. And there's also a $sign and an M and a 5. So $sign, M, and 5. And remember that when we're talking about sets, we start and end with braces, and then we have commas in between. And also remember the order does not matter. So if you wrote $sign, M, 5, and then a square and then a triangle, you're fine. That's fine. Then I want to know what is in the set A. So the set A is represented over here by this circle. So if I'm asking you what is in set A, I'm asking you what's inside this circle. So you would just say that's a square and a triangle. And then the other thing I can ask you is what are the elements in U, so inside the rectangle, that are not in A? So I need to be in the rectangle but not in the circle, and that's these guys over here. So that would be the $sign, the M, and the 5. So if I'm talking about things that are not in A, it has a special name right here. This A with the apostrophe on it means elements that are not in A. So this means, and then the other way that you can say it is you can say A prime. So if you see this symbol, it means what is not in the circle with A. So if I ask you for A, I want to know what's in the circle. If I ask you for A prime, I want to know what's not in the circle. All right, we're going to practice drawing some Venn diagrams here, and these are just different situations that you can see. So disjoint means not joined. So remember, we're going to start with a rectangle. If you have disjoint sets, that means that you're going to have two circles, or it could be three, and they're not going to overlap or touch each other at all. So this could be students in my class that are in the classroom and students in my class that are not in the classroom. You can't be in both circles at the same time if you're in a disjoint set. So disjoint means not joined. There's nothing in common. They cannot happen at the same time. Proper subsets. So remember from a video or two ago, if you have like A is a proper subset of B, that means that every single thing that's in A is in set B, and also there's less things in A than there are in B. So in a Venn diagram, the way that that's going to show up is you're going to have your rectangle, and you're going to have a big circle, and you're going to name this big circle B, and then you'll have a little circle inside, and that one is going to be A. So if A is a proper subset of B, it's going to look like this in your Venn diagram. So this could be something like the set of all the presidents of the United States of America could be in here, and this circle could be men. And that means that every single president of the United States has been a man. Equal sets means, remember, equal means that they have the same number of things, and they're the exact same. So equal sets, you're going to have like two circles like right on top of each other. This one, you're not really going to see much, but it's like two circles right on top of each other. So that one is not useful. It's not interesting to look at, and it doesn't teach us much, but it's a possibility. And then the last one on this page is sets with some common elements. This is the one that you're familiar with. So inside our rectangle, I'm going to have two sets or three, it doesn't matter. And they're going to have some common elements. So this is where they overlap. So if I have some things in common, they overlap. If I have everything in common, they're equal. If everything in A is also in B, they're going to look like this. It looks like an egg or like an avocado. And if nothing's in common, they're going to look like this. Okay, let's talk about this problem. So I pulled this image from your homework, your math lab homework, just so that we can work with pictures that look like this and you won't really wonder about it whenever you get there. So here I've got my rectangle with my U. And if you see these Roman numerals, 1, 2, 3, and there's a 4 down here, these are not parts of the sets. These Roman numerals are talking about like areas of the picture. So these Roman numerals are saying that just this little piece over here in A, this little like crescent over here has A, B, and C. Area 2 is containing the letter D. Area 3 is containing E. Area 4 is containing F and G. And your homework in Math Lab is going to ask you things about the areas on there. So that's what these are there for. So let's use this Venn diagram to determine who is in the universal set. So remember, that means everybody in the entire rectangle. So it's A, B, C, D, E, F, and G. So we're going to open with a curly Q. A, B, C, D, E, F, G. The order doesn't matter, but I usually will write letters in alphabetical order because I'm pretty boring. Okay, set B. So here's my set B right here is this circle. That means I need to name every single thing that's inside this circle. So that would be D and E. So set B only has two elements in it. Now I need the set of elements in A, but not in B. So if I look at everything that's in A, everything in this circle, it's A, B, C, and D. But I only want the elements that are in A but not in B. So I don't want this one right now because it's also in B. D is sitting in A circle and it's sitting in B circle, and I don't want it for this problem. So this one, I just want A, B, and C. Okay, the set of elements in U, so inside the rectangle, that are not in B. So I need to find everybody in this whole rectangle and take out everything that's in this circle. So that would be A, B, C, F, and G. So A, B, C, F, and G. And then this one is the set of elements in both A and B. So they have to be sitting in the circle for A and also sitting in the circle for B. There's only one element that satisfies that, it's D. All right, here is the definition of A complement again. So the complement of set A, which is A prime right here, is the set of all elements in the universal set that are not in A. So A prime, this is how you write it in set builder notation. I won't make you do that. So let's draw a picture so you can visualize that. So if I have a Venn diagram here, and I'm going to put my two circles. So I'm going to name this one A and this one B. If I want to find A prime or A complement, so I want all the things in the rectangle that are not in A, it's all of this and all of this and all of this, and it's also inside here. So this pink shading would represent A complement. And this is going to be, I don't remember if it's on your homework or your group assignment, but you're going to have to shade in some boxes like this to show where these things are happening. So visually, this is where A complement is. It's everywhere in the rectangle that's not in the circle named A. But sometimes you're going to have a list of elements and you'll need to find A complement. So if U has all the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, A is 1, 3, 4, and 7, and I ask you to find A complement, that just means what numbers are in this set, but not in this set. So you can just look at these numbers and figure it out, or if you want to, you can draw a picture to help you like visualize where things are at. So A has 1, so I don't want that one in A complement. 2 is not over here, so I do want that one. 3 is in A, so I'm going to skip it. 4 is in A, so I'll skip that one. 5 and 6 are not over here, so I'm going to put those in A complement. 7 I see in A, so I don't want that, and then 8 and 9. So that's how I would figure that one out. But if you want to draw a picture, so you can draw your U, and then your circle can be A. I know that I have 1, 3, 4, and 7 inside A, and all these other numbers are in U. So I have 1, but I already wrote it down, so I don't need to write it again. 2 I don't have yet, so I'm going to put 2 out here. 3 and 4 I put in here. 5 and 6 are not written down yet, so I'm going to put them out here in the rectangle. 7 I already wrote down, but I forgot a comma. And then 8 and 9. So if you want, you can draw a picture like this to help you see where your numbers are sitting in the rectangle if you're a visual person. Okay, your next definition is called the intersection. So intersection, if you think about where two roads meet each other, like if you have a road here and then you have a road here, the intersection is right here where they're overlapping. So the intersection of A and B is that little overlap where the two circles overlap each other. So I'm going to draw a Venn diagram here so that we can visualize this. So I've got A here and B here. So the intersection of A and B is whatever's common to A and B. So it's this little piece in here. And this is how you write it. A little upside down U means intersection. So A intersection B for this picture is this little area right here. So if I ask you for the intersection, I want to know what do they have in common. And if you see a picture like this and I say, what's the intersection? You'll tell me what elements are sitting here in this little piece where they overlap each other. So let's find the intersection of two sets. So these don't have pictures, but later on we will. So if my first set is 7, 8, 9, 10, 11, and I want to find the intersection with 6, 8, 10, and 12, I just need to know which numbers are sitting here and also sitting here. So 7 is not over here, but I see 8 in both, and I see 10 in both. So the intersection is just 8 and 10. It's what they both have in common. What about this one? 1, 3, 5, 7, and 9, and then 2, 4, 6, 8. Do they have anything in common? These two sets don't have anything in common. So their intersection is the empty set. Remember that guy? Oh, you don't need the braces though. You can just say this. You can just say the circle with the line in the middle, or you can do braces with nothing in between. And then this one, I have 1, 3, 5, 7, and 9. And then I want to intersect with the empty set. So if I have the numbers 1, 3, 5, 7, 9 sitting in a bowl over here, and then I don't have any numbers sitting in a bowl over here, what would they have in common? These guys also don't have anything in common. This is also the empty set. I can't have an intersection with the empty set because there's nothing in the empty set to have in common. Okay, here's some pictures. So if I want to find the intersection of these two circles, it's right here. It's where D and E are sitting. My printer needs more ink, guys. Okay, over here, remember this is proper subsets, so I have 1, 3, 5 right here, and I have 2 and 4 right here. The numbers that they have in common are 2 and 4. So 2 is in the small circle, and it's also in the big circle. 4 is in the small circle and the big circle. 1, 3, and 5 are only in the big circle. So 2 and 4 are my intersection. And then over here, I've got Picard, Kirk, and Data. And over here in this circle, I've got Chewie, Yoda, and C-3PO. These two circles don't overlap. They don't have anything in common. So the intersection here is the empty set again. The best friend of the intersection is the union. So the union, you can think about coming together, holding hands. Just kidding, we don't hold hands right now. It's represented by this symbol, and that means everybody in A and also everybody in B, and you're going to squish them together and make one big, huge set. So if I'm going to draw a picture, so I've got A here and B over here. A union B means take everybody in A and smash them up together with everybody in B. So it's everything in A and also everything in B. So if I ask you for A union B, I want everybody in both sets. What they have in common and what they don't have in common. I want them all. So down here, let's practice with some numbers. So if I have this set, 7, 8, 9, 10, 11, and then I also have 6, 8, 10, and 12, and I want the union, I want to write a set that has every single number on the left and every single number on the right. But you got to be careful. We don't want any repeats. It's not wrong to have repeats, it's just redundant, and we just don't need to write things more than once. Remember, order doesn't matter, but I will write them in order from smallest to biggest because it helps me organize my numbers and keep them straight, and also I like it better that way. So I've got 6, and you can kind of mark them out as you go along. Then I've got 7, just to make sure that you catch them all. I have 8 in both of them, but I don't want to write 8 twice, I just want to write 8 once. And then I have 9, and then I see 10 in both, but I'm only going to write it once, and then 11, and then 12. And then because I marked them out as I went along, I made sure I didn't forget anybody. Let's look here, 1, 3, 5, 7, 9, and 2, 4, 6, 8. If I want the union, I want all of these numbers and all of these numbers. And these aren't going to have any repeats. So it's just 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you're feeling fancy, you could also do like 1, 2, 3, and then dot, 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 7, 8, 9. I don't know that it really saves you that much writing, but it's an option. What about if I'm doing a union with the empty set? So if I have 1, 3, 5, 7, 9, and then I also want to tack on the empty set, I'm just going to be left with what I had. This is like adding 0. So if I have something and I add nothing, I have just what I started with. So 1, 3, 5, 7, and 9 is going to be my union right here. Let's look at these pictures. It's the same pictures as the ones before. So if I have A over here and B over here and I want the union, I just want every single element that's in both circles. So my union would be A, B, C, D, E, F, G, and H for this picture. For this one, I need 1, 3, and 5, and also 2 and 4. So 1, 2, 3, 4, 5. Over here, these guys are not touching each other. They don't have anything in common. But for a union, I don't need anything to be in common like these two pictures. A union just means write down everybody in the first set and everybody in the second set, but don't write anybody twice. So this one will be Picard, Kirk. I'm not going to write out the words. Chewie, Yoda, and C-3PO would be in my set. So it's just everybody in both circles. Okay, so we talked about this, but here's just like some little shortcuts here. So maybe draw a special bubble around this. If I have a set and I do the intersection with the empty set, I get the empty set. If I try to find what's in common between some stuff and nothing, nothing is in common. And then if I do the union, you're going to end up with what you started with. So if I have a set and I add on 0, I'm still going to have whatever I started with. So now's the fun stuff. So I'm going to give you some sets, and I need you to find these things. These things are just getting more complicated. Sometimes it'll be helpful for you to draw a picture. You don't have to every time, but I think it might help you guys. So, and then one thing to remember, you should always do parentheses first. So if you see some stuff inside parentheses, you need to do that first. So here's my universal set. Here's A and here's B. I'm going to go ahead and draw a Venn diagram of this because I think it's easier to look at the picture. I'm a pretty visual person, so I like to see all the things written out. Okay, so A is 1, 3, 7, and 9. B is 3, 7, 8, and 10. So the first thing you need to decide is if any numbers are going to go here in the overlap. So I see 3 and 7 in A and in B. So I'm going to do 3 and 7 right here. And I'm going to cross these out just so I know I've already used it. So in A, I still have 1 and 9. So I'm going to have a 1 here and a 9 here. In B, I have 8 and 10. So I'm going to put an 8 here and a 10 here. I'm going to put some commas in between just so that we don't get too confusing. Okay, now my universal set has numbers all the way from 1 to 10. I already wrote 1 and 9. I wrote 3 and 7. And I wrote 8 and 10. So since I've already written these inside my rectangle, I don't need to write them again. But I haven't written yet 2, 4, 5, and 6. So those are going to go out here. 2, 4, 5, and 6, not in a circle. They're not in set A and they're not in set B. So they're going to go out here in my rectangle. So here's my representation of these sets. Now I need to find A union B complement. So let's start with the parentheses. A union B, you need to decide first, does that mean smash them together? Do I want everything in A and B, or do I want where A and B just have in common? So a union is everything in A and B. So if I think about all the things in A and all the things in B, they're sitting right here in these two circles. And remember, this little apostrophe means complement. So this means find where A and B are and think about everything that's in A and B, and then tell me what's not in A union B. So that would be 2, 4, 5, and 6. And I think because we have this picture, it's a lot easier to think about finding the union and then what's not in the union. I think this picture is much easier to look at. So if I were you, I would draw a picture whenever you're doing your homework, even though it doesn't like require you to. Okay, this one, I don't have parentheses. So I just need to think about A complement and B complement, and then I need to find the intersection of those guys. So this is where some highlighters might be nice. So I don't have room to draw my picture again, but maybe I should. I'll draw it on the back of this paper. Okay, I drew my Venn diagram again just so that I would have some room to color. So if I am thinking about A complement, that's everything that's not in A. So I'm going to shade that on my Venn diagram here with my yellow marker, just so that I can see visually where that's happening. So everything that's not in A is where my yellow marker is. It's all around the circle. And then I also need to think about everything that's not in B. So that would be everything outside of the circle B, of the set B. So that's that. Okay. Now I need to figure out where these guys are overlapping. So remember, intersect means overlap. So I need to figure out where the pink and the yellow are overlapping each other and name all the numbers that are sitting there. So inside this little circle here, I have 1 and 9, but there's no yellow happening here. I don't have any color in the like right here with 3 and 7, there's no coloring happening here, so I don't want that little piece. Over here where the 8 and 10 are sitting, I only have yellow. That's not what I'm looking for. I'm looking for yellow and also pink to be overlapping with each other. So the only place they're overlapping is out here, outside of both of the circles, which is where 2, 4, 5, and 6 are sitting. So if you'll see, this and this gave us the exact same sets, but they could be written different ways. Just like 5 plus 1 is 6 and also 2 plus 4 is 6. So sometimes you'll be given two different things to figure out and you'll end up with the same set, and that's totally fine. Okay, here's a practice problem. If you were with me in class, I would ask you guys to do this, like with your next door neighbor, and then I would walk around and help you, and then I would give you the answers. So if you want to, you could pause this video and then work through it and see how you do, and then come back and see if you got the same answers as I did. So this one, let's do A union B. So I want everybody in A and also everybody in B, and I want the union. So I just want to list everybody that's in both of those circles right here. So that's 2, 4, 5, 1, and 3, and also 9 and 12. So 2, 4, 5, 1, 3, 9, 12. Hopefully you got that one right. A union B. My printer is pooping out here. Okay, so now I want A union B complement. So we already figured out A union B was everything in both of these circles. If I want the complement, I want everything outside of both of those circles. So that's going to be 6, 7, 8, 10, and 11. So 6, 7, 8, 10, 11. Okay, now I want A intersection B. So that means where do A and B overlap each other? Intersect means overlap. So that's just this little piece right here, this little yellow with 1 and 3. Now I want A intersection B complement. So I found the intersection of A and B. It was this little yellow piece. If I want the intersection but the complement, I want everything that's outside the yellow. So that means I want 2, 4, 5, 9, 12, and also 6, 7, 8, 10, 11. So 2, 4, 5, 9, 12, 6, 7, 8, 10, 11. And you could go back and put these in order and do like 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. But you don't have to for me. But sometimes your math lab homework will make you put them in order. So you just need to do whatever math lab tells you to do. Okay, let's look at this one. I have A complement intersection B. So this might be a good time to use some like shading. You could also use like a light pencil if you don't want to like bust out your kids' markers. So A complement is everybody that's outside of A. So that's everybody outside of A. B is inside this circle right here. So I went that way. And then A complement intersection B means where do my lines overlap? So my little hash marks are overlapping just right here with 9 and 12. Okay, for this one, A union B prime or B complement, I'm going to redraw this Venn diagram down here so that I can color on it. Okay, I redrew my Venn diagram. I like colors instead of shading with the pencil. So I'm going to make A be pink. So A is everything inside this circle. B complement means everything that's not inside B. So that is going to be everything out here because that's not inside B. And it's also going to be inside here, right here. And then you need to decide what that U means. Does that U mean write every single number that has pink or yellow, or does that U mean only where they overlap? Whenever it's a U, it's a union. We're coming together. So I want every single number that's touched by pink and every single area that's touched by yellow and also where they overlap. I want it all. So A union B prime is going to be all the numbers except for 9 and 12. So it'll be 2, 4, 5, 1, 3, 6, 7, 8, 10, and 11. And there's that set. Okay, this is our last page. So here's a handy formula for figuring out how many things are in the set of A union B. So it's all the things in set A plus all the things in set B, and then you've got to take out the number of things in the overlap so you don't double count them. You do not have to have this formula memorized. It's just a handy little formula. It's a nice way to think about it. So if I have everybody in A and everybody in B and I take out where they're overlapping, then I just take out things that I counted twice. But you can also always draw a picture of a Venn diagram and just count that way. So let's do that. Let's draw ourselves a Venn diagram for this information. So we did a blood drive survey and it indicated that 490 students were willing to donate blood. 340 students were willing to help serve breakfast to the blood donors. And 120 students were willing to do both. Oh, I need another color. All right, 120 students were willing to do both. So we need to represent this with a Venn diagram. So remember, you need a rectangle. And then you need to decide how many circles you're going to use. So if I'm talking about donating blood and serving free breakfast, I only need 2 circles. And I'm going to write donate right here. And then I'm going to write breakfast right here just to help me organize my thoughts. Okay, what you need to do when you're doing a Venn diagram is you need to start with the overlap. So I know that 120 students were willing to do both things. They were willing to donate blood and also serve breakfast. So I need to put 120 in here. You need to start from the inside of your Venn diagram and work your way out. So I have 120 here. I'll put that in purple to help us keep everything going. All right. So if I had 490 students that were willing to donate blood, I can't put 490 right here because I've already talked about 120 of those students. So I have to do 490 minus 120 to figure out the number that's going to go right here. So whip out your calculator and do 490 minus 120, and you should get 370. So that's what I'm going to put in here. And then if you want to double check yourself, you can just real quick do 370 plus 120 and make sure you get 490. So these two numbers are going to add up to how many students were willing to donate blood. If 340 were willing to serve breakfast, you have to take out the 120 that I've already talked about to figure out how many people are going to live right here. So do 340 minus 120 in your calculator, and you should get 220. And if you want to double check, do 220 plus 120 and make sure that you get 340. So now that I have all my information organized in my Venn diagram, I can ask you lots of questions about it. So for instance, I can ask you how many students were willing to donate blood only? Well, that would be 370. Or serve breakfast only, that would be 220. If I ask you like in the same question, so 370 were donating blood, 220 were only going to serve breakfast. If I just ask you like how many are going to donate blood, you just write 370. But for this one, whenever you see this on your homework, when it says how many were willing to donate blood or serve breakfast, you would add those together. So 370 plus 220 is 590 students. We're willing to only do one of the things. So make sure you start in the middle. And then to figure out how many people are going to be sitting here, you got to subtract the middle. To figure out how many people are going to be sitting here, you also subtract the middle. And then I would double check if I were you just to make sure that everything's adding up. And once you get this picture drawn, you can answer all the questions that I can ask you about it.